So, let's begin again with the telencephalon. The telencephalon would be the rostralmost subdivision of the adult human brain. So the telencephalon is all of this you see on the lateral surface, and it's also all of this you see on the medial surface. And the telencephalon is the most recently evolved area of the brain. And its function is going to be the focus of many of the lectures of this course, because it is the outer surface of this telencephalon, just the outer rim of it, which we know is called the cortex, which is believed to be the seat of the mind. So it is the outer part of the telencephalon which will be the focus of many of our lectures. This enormous elaboration of this outer part of the telencephalon, the cortex, is in fact what is associated with the human brain. And so we see that the cortex is very enlarged. If we look at the brains of other animals, their cortex is much smaller, and we'll talk a little bit about how our brain differs from that of animals in some of the other lectures. But if we were to look in any specific area of the cortex and to make a little tiny, take out a strip of cortex through, say, the 6 layers in neocortex, we would discover that there's a vertical organization. So in a drawing we've made here shows you that this is just one gyrus here. This would be a sulcus. You take a strip of cortex about 1 to 2 square millimeters. You take it out and look at it. Say it is in neocortex, goes through all 6 of the layers. This little tiny strip is an independently functioning module. And how all these modules are connected to each other is one of the, understanding that is one of the goals of modern neuroscience.
In a report published recently by Nebula Genomics, the primary data set included over 150,000 patients aged 40 and above. Among these, 700 were diagnosed with Parkinson's. When compared to about 100,000 controls, 2 specific retinal layers, the ganglion cell interplexiform layer and the internuclear layer, were noticeably thinner in Parkinson's patients. In 2021, this examination showed my left eye had some problems with thinning retinal wall. And in 2023, 2 years later, it was healed up. 2021, we had some spotting out here in the left eye, meaning thin spots in the retinal wall. Here it's considerably healed, but the left eye is going slower than the right eye. The right eye, we have good retinal wall, except there's some thin spots here in the center, especially one right there. Looking at the right eye in 2023, it's looking thick and plush. That thin spots healed up completely.
Part of the eye is actually an outgrowth of the diencephalon. So the eyeball is one of the only areas, in fact, the only area of the body, where when the doctor looks in your eye, he can see the back of the eye, and that back of the eye is actually an outgrowth of the brain. So it's the only place in the body where you can see a part of the central nervous system in the living person.
So while the cortex is the same thickness in all animals, in all species that have a cortex, the increase in the surface area in the human brain allows for an increased number of areas and an increased number of these little functional modules and their interconnections with each other. And this is what's allowed the increased information processing ability that we have as human beings. So this is just so critically important to understand. Another individual who was part of this group was an individual named Christopher Wren. Christopher Wren, of course, being more well known for his having been the architect of St. Paul's Cathedral. And so this is an individual who was part of this Oxford group. Willis was one of the first individuals to describe many neurologic and psychiatric disorders. In 1664, he published The Anatomy of the Brain and Nerves. And this book helped establish that perception, movement, cognition, memory were all functions of the brain substance itself. Now, what is interesting in this regard is his observations were actually accompanied by beautiful and detailed anatomical drawings that were made by Christopher Wren, again, our great architect who went on to design St. Paul's Cathedral in London. This is one of Wren's drawings that is in Willis's book, and it shows the ventral or undersurface of the brain. It could be used today to teach medical students. It is so accurate. Just a really dynamic group of men at Oxford at that time.